Hi students, we were discussing about Newton's laws. So just recall Newton's two laws which we discussed. Newton's first law of motion states that an object remains in a state of rest or in uniform motion in a straight line until unless when we applied a force. So to change the object state, we need to apply a force. And this is also we define in terms of a law. So law of inertia. So inertia is nothing but it's a tendency. It's a natural tendency that objects remains in the state of rest. So this we defined as Newton's first law, and we discussed so many examples. And we discussed the Newton's second law. So the Newton's second law says that the rate of change of momentum of an object is proportional to applied force in the direction of force. So Newton's second law gives a formula for force, F equal to ma. Force equal to mass times accelerations, and units are newtons. So to define force, we need to define momentum first. So we define momentum as nothing but momentum P equal to the product of mass into velocity. And to define force, first we need to define rate of change of momentum. So this is just like cutting process. We need to go step by step. So first we define momentum. So then after we need to define change in momentum. Suppose u is initial velocity and v is final velocity. So mu is initial momentum p suffix I, and mv is final momentum p suffix f. Now we write the change in momentum. Change. So mv minus mu, that is known as change in momentum. But here it is the rate of change of momentum. So rate means rate of. We need to divide with the time. That is simple memorable point. Rate of change of momentum means we need to divide with the time. Suppose if I take it out that m common, and that is v minus u by t. So from first equation of motion, v equal to u plus at. Now you can write that a equal to v minus u upon t. So in the place of v minus u upon t, I can substitute ma. So this gives me formula for force. So first we need to define momentum. Then after we need to define change in momentum. Then after we need to define rate of change of momentum. So finally, in the place of that value v minus u upon t, we can substitute acceleration. That gives me F equal to ma. So this gives the Newton's second law of motion formula. So we can define that the Newton's second law, the rate of change of momentum is directly proportional to applied force. In a simple manner, if you can write that F equal to ma. So this is Newton's second law. Now today I am going to talk about Newton's third law, very important and very interesting. Newton's third law. So a simple statement, Newton's third law says that To every action, there is an equal and opposite reaction, and they act on two different bodies. Remember the statement? To every action, there is an equal and opposite reaction, and they act on two different bodies. So to happens Newton's third law, first we should have two different bodies, two different things. So one thing will be exert action and another thing will be shows reaction. So in a simple statement we can say, for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. So let us understand this statement with the help of examples first. I would like to talk so many examples. So let us talk about the example which can easiest first. The motion of rocket works on the principle of Newton's third law. So rocket motion, to move this heavy body, rocket is huge mass, it's having so much weight. So the rocket is moving forward. So to move rocket forward direction, that is the direction of motion of rocket. So here you can see the flame, the fire which is coming out from the rocket. So that flame pushes the rocket upward direction. If you can play, I can play it again. So rocket is moving, so that is action. So moving forward, so that is action. So that is reaction. Moving forward is reaction. So that is reaction due to the fire which is pushing fire on the downwards, that is action. So here it is action. So when fire burns and because of that pushes downward direction, then rocket moves upward direction. So this shows that action and reaction. So rocket is moving due to because of that action. So we can observe that one more time again at here. So if the rocket is moving the forward, so that is reaction, and fire is pushing backward, so that is action. So rocket works on the principle of Newton's third law. It works on the principle of Newton's third law. So that is, so downward is action and rocket moving upward, it is reaction. Now let's see one more example. Suppose if you see, when we fire a rifle or gun, so the bullets will come out. So if you can observe this action carefully, so when we fire that, so the bullet is coming the forward. Let me play this again. It's very small time. Yeah. So if you can closely observe this one, when bullets are coming the forward, so this is bullet. So bullets are coming the forward, so that is action. The bullets will come out. And when you can observe, and he is moving the backward, so the rifle is moving the backward. Now he is moving the backward because the gun will exert force on the shoulders, and this is called reaction. When the bullet comes forward and that bullet exerts a force on the rifle, so that's called reaction, and this force is also called recoil force. You can check bright color, so if you can see, it is recoil force. So these two examples, if we can see together, the motion of a rocket. So it is also works on the principle of action reactions, and the bullet and the fire. The bullet is which is coming from the gun, the bullet is which is coming from will exert a force on the rifle, so that tells about reaction. So these are the very common simple examples we can understand it, which works on the principle of Newton's third law. So that is known as action and reaction. Now let's see some other general examples. If you can play it here, see here, while we are swimming and while we are boating. So these all are the general example for the action and reaction. So when rocket moves forward, so that is due to reaction, and the rifle moves backward, that is due to also reaction. And when we are swimming, when we are applying a force, so the reaction is we will push the water backwards, then we will move forward. So here pushing water is action. So we will push water backwards. While we are swimming, we have to push water. So how much water we will displace? So the water will apply force on. So this is the pushing water backwards is action, and moving forward is reaction. So it is also action and reactions. And similarly, when we can push the boat, and when we push the boat forcefully, so that is action, and moving the boat forward, it is reaction. So we have to apply force. So here he is applying force, and he is applying force on the water with the help of this pedal. So he is pushing, so the water will push, the water is pushes, so this is action. So the water pushes, so this is action, and the boat moves backwards, so that is reaction. So this is also one of the general example for action and reaction. And more important is that when we walk, so we will apply force at here, because in the first step we will apply force, and this is our action. So this is action, and the reaction, the earth will be apply force in the backwards, and this is at here, it is reaction. When we walk, we need to apply force on the ground, so that leads to the action, and the ground is also apply force on our foot, so that is goes to reaction. So let us see one more example, so later I can discuss our textbook examples. So when we walk, so that is also with the help of the Newton's third law. See at here, when we are jumping on the diving board, so this is called as diving board, and we need to apply force at here. So if we can apply force at here, and this is action, because we will push on that diving board, so that is the action. and the diving board will push up. So here see, so the boy is jumped up, so that is due to because of reaction. So because of this diving board, when you push the diving board down, and the diving board will push us upward direction. So this is also due to because of action and reaction. So these all are the general example for Newton's third law, which are very interesting. And see the flying mechanism of bird. The bird is flying in the air, so it will flip its wings. When it flips its wings, the bird is applying force on the air. So here it is action. It is applying, it is flipping just like that, it is waving. So that is action. So because of that the bird is flying, so that is its reaction. So in the reaction also, the air will be the pushes upward direction or over the flips. So the bird, it won't fall. Now here you can see the air is applying force and this is reaction. So when the bird flips, so it has to do the action, and oppositely here we need to do that opposite, that is known as reaction. So let us see the same example. First I will discuss the easiest one. So as example we saw so far, so these are the same example, the recoiling force of gun, so that gives us reaction force. When the bullet is coming the forward, so that is leads to action. When we fire a bullet, so the bullet will becomes forward direction, so that causes action, but the gun will be acts on the shoulder, will apply a force on the shoulder. So that force known as recoil force on the gun. So that is due to because of reaction. And one more example, ours here it is. Suppose if you are jumping from boat to land, suppose it is, you can take as land, and you are jumping from the boat. So boat is on water. So what happens if you can jump? The boat will move backwards. It means you are applying force on the boat. If you are applying force on the boat, so that's called as action. So because of that action, we are jumping on the land, so that is known as reaction. So without applying a force on the boat, we cannot jump. Similarly, this is also the same example when we walk or when we run. Always we need to apply force on the surface of the earth. So that's also leads to the example of Newton's third law, action third, reaction. So as I discussed about the rocket principle, so when a rocket is fired, the force of the burning gases, so the burning gases are applying a force in the downward direction, so that called as action, and because of that the rocket moves upward direction, so that is the reaction. So when a rocket is fired, the force of the burning gases coming out, action exerts an equal and opposite force on the rocket. Now you just imagine the weight of the rocket. If the rocket is huge, very heavy, so then the gases should exert more force, then only the rocket will move upward direction. So we can do one small similar the rocket experiment at here. Suppose I am having a balloon. So this is an inflated balloon. So this is a tie up a rope with the help of a straw. With the help of a straw. So how the air is pushes in the backward direction, if you can consider this as action, and the balloon will move forward direction, this is reaction. So these all are the examples of Newton's third law. So very first example, as we discussed, the recoiling of gun and pushing water, and this is something we need to talk about, action and reactions. So from this, if we can take, I'm having two springs, so this is a spring 1 and this is another spring, and they both are connected. So here you can see they both are connected. Now if I apply force on spring A, I am pulling. So if we can pull in this direction, so that is my action. Now since they both are joined at here, so what happens, and this spring also will be moved in this direction. So if I consider this is my action and this is reaction, and how much force I pull, here it is, the force is 100 newtons, the same force also will be acts at here. So this shows that the forces exerted by the spring balance A on B. So here the force is coming due to because of A, because I am pulling spring A only, I am not pulling spring B, but A is connected to B. So if I am applying a force on spring balance A on B, and it is also applies an equal force in the opposite direction. So if we can draw an arrow marks at exact joint at here. So if this is the applied force, and this joint will be apply a force on in this direction. Now this consider if we take as action, and this will becomes reaction. So the force, both are exerting each other. The force exerted by the spring balance A on B is action, and the force exerted by the spring balance B on A, it is the reaction. So these all are the general examples of Newton's third law. Let us see this in the demonstration. For every action, there is an equal and opposite reaction. So this statement is the Newton's third law.